With your robotic system, it is sometimes necessary to increase or decrease speeds, change certain values of how the system is currently running. To do this, we've actually supplied several options for you as the user to be able to set it up specifically to how you want your system to run. To do that, we're going to come down here to Settings. Under Settings, we're going to go to Advanced. And under Advanced, we're going to say these settings are critical. We're going to say checkmark. Now I want you to make sure that as you come in here that you only adjust the pieces that we're discussing, which we're going to be discussing acceleration, curvature, and lead line speed. I would highly recommend you do not adjust these other 6 settings that are over here, the KPs, the KIs, and the KDs. Okay, so some machines are heavier than others. Some carriages roll smoother than others. Because of all of these factors, the robotic system tries to accommodate all of the pieces as best it can, but it sometimes does require me as the user to adjust some of the settings to make my system roll best or move best. Let's say, for example, if your machine is heavy. I have a really heavy machine, 50, 60, 70 pound machine. My system, it runs well, but as I come into corners or as I come out of the corners, my system seems to become a little jerky. Well, what happens is as I'm coming into that corner, so imagine that right here on the screen, as I'm coming into this corner, it's accelerating and it starts to decelerate for the corner and it stops for the corner and then it starts to move out of that corner again. But because of my acceleration, because of how my system is currently being driven, it accelerates too quickly out of the turn. So it comes into the turn and then it kind of jumps out of the turn again and accelerates too quickly, and because of the mass or the weight of my machine takes a little bit to get up to speed, and so what happens is my machine starts to push the robotic system around and I get this kind of jerky motion like this on the screen. And my machine actually starts to kind of jerk as it gets up to speed. So what we can do is we can change our acceleration and our curvature. I want you to think of both of these like driving a car. My acceleration is when I'm at a stop, when I'm at a corner, when the system comes up and it makes that corner and it stops the corner and it turns back in opposite direction, or even it stops at the corner and starts this 90-degree direction. Any corner the system does have to, in theory, stop and change direction. That's where acceleration is going to come into play. And so if my system, it weighs a lot, my system's quite heavy, and the robotic system gets moved around by the weight of my machine a little bit, I can come through here and I can press on acceleration and I can actually turn it down. What this means is, like drive my car, what this means is I'm only going to press my accelerator down of my car 20% instead of 40%. And this is up to my currently set max speed. So right here, when we go to run our system, you can see right here, we push check mark, right there on the screen, this is the speed that my system is going to currently run, and I'm currently running at 30% or 30 speed. So with that, under my acceleration, if I'm set to 20, what it's going to do, it's going to push the gas pedal down 20% to get up to that 30% speed. It's going to take longer for it to accelerate up. And again, I may need to do this because my machine weighs more than other machines. On the curvature side, a very similar concept. This one only applies to a curve. So you can see here on the pattern, I've got a 4-leaf clover. Every time it comes down and comes around one of these curves, it's actually going to slow down. It's going to let up off the gas pedal about 60% down to a 40% speed or a 40% curvature. And when I said 40% speed, I don't mean 40% speed, I mean 40% of my max speed, so that 30. So if I'm decelerating down to 40%, it's going to be more like a 13 or 14. Now that is a little bit slow, but as the system is running, depending on the size of your pattern and depending on the weight of your machine, that may be best for your machine to run best and for your pattern to look best. Now on some models and on some patterns, my system is quite open. It doesn't have a lot of turns. It doesn't have a lot of stops and starts. And at the end of the day, naturally, I want to get through the pattern as quickly as possible. So because of that, I can actually come in here and I can actually adjust my acceleration up to 80. So what that means is on my curves, on my starts and stops, it actually will slow down very little. It will wait till almost the last second to slow down until it makes that turn. And once I make that turn, I will push the gas pedal down to 80% to get up to my max speed, which again, we are set to 30 for my max speed. It's going to accelerate and decelerate a lot faster than on my 20. Same thing for curvature. If I bump this one up to 80, that's going to then give me a faster curve. It's going to slow down less as it goes around the curves. So acceleration, the lower the number, the longer it's going to take to accelerate. Curvature, the lower the number, the slower it's going to go around the curves, and vice versa. The higher the number, the faster it accelerates. The higher the number, the faster it's going to go around a curve. Down here, lead line speed. When I am going from wherever my machine is currently sitting to the beginning or the start point of my pattern, that is what we call the lead line. I'm just going to let this pattern run just a little bit down through here. And we're going to say OK. And it's going to start to just trace. It's going to trace this pattern just a little bit as it comes down through. And this is just so I can get it away from my start point. OK, so we're going to stop right there. All right, so where my crosshair is currently sitting to my start point, it's going to make a straight shot right from here all the way to the start point. That's what we call the lead line. So coming back here, my lead line is going to run at 80% speed. And you might say, well, that's kind of fast for my heavy machine. But if you think about it, this pattern, this line right here that it's going to run, it's not going to stitch it. It is just going to move to the start point. It is not extremely important that this line is very accurate in how it moves to the start point. Yes, we want it to be accurate to the start point, of course, but how the line is moving, whether it's pulsing because my machine is a little bit more heavy or things like that, that is immaterial because we want it to get to the start point as quickly as possible. And yes, we want it to be accurate to the start point. This speed here does not define accuracy to the start point. All this speed here defines is how quickly it goes from where the machine is currently sitting to the start of the pattern. Now, one other setting that I want you to be aware of is right here, the min speed. Min speed is currently set to 3. On those machines where the stitch regulator just doesn't respond extremely quickly, that the stitch regulator specifically doesn't like slow movements, and sometimes it takes your machine a little while just to get up to speed. I've even seen those models where if your machine's a little bit cold, your motor's cold, that it just takes a little bit longer for it to speed up or for it to acknowledge movements of your carriage. Because of that, we can actually come in here to our min speed and we can adjust the speed up. This is like in your car when you let off your brake pedal but have not yet pressed your gas pedal. That right there is what we call an idle speed in your car, or min speed for the robotic system. What is the minimum speed the robot is going to move? So right here, let's call this in a percentage. This is going to move a minimum of 10%. So it's going to be a little bit, obviously, 3 times as fast as, or 3 times plus as fast as our 3 speed we currently had it set to. The benefit of that is on my machines that don't really like going slow, this will actually move my machine in a faster motion. Now, the only downside is when I start to throw in those accelerations. The accelerations and the curvature pieces that we have over here, obviously I want to have those bumped up a little bit higher so that my system never goes too slow to account for my stitch regulator of my machine. So min speed, curvature, and acceleration are 3 pieces that are going to be important for you to understand to make your stitch regulator and your robotic systems play nicely together. Please take a look at our Quilt-EZ YouTube channel for other videos and other updates on the system as to how to use your robotic system better, more efficiently, and more accurately. And then, of course, check back to our website often to see when we are doing our live webinars to give you an opportunity to be able to ask questions and to learn more about your robotic system as well. Thank you.